is Lance Benson. I'm a project manager and a steel detailer for JBI Construction in Fountain, Colorado. Just to give you a little background, I have been welding for approximately 34 years. I ran my first bead when I was a freshman in high school. I later opened my first fabrication business when I was around 25 years old. I was self-employed for around 12 years where I learned a lot of hard lessons. It was about 14 years ago that one of my best customers offered me a job, and I couldn't refuse, and that's where I currently work. Over the years, I've worked on many exciting projects, including multiple projects for World Wrestling Entertainment, like the Elimination Chamber, the Spider, and the Crab. Another favorite was the exterior video towers at the new Dallas Cowboys Stadium. My day-to-day projects are varied across 5 military installations in the Colorado Springs area. There's never a dull moment in my little world. Alright, let's get on with it. For this class, keep in mind I do understand that every shop is different, and we have all learned our trade from different people. Therefore, our methods vary from fabricator to fabricator and from shop to shop. I'm only sharing my point of view based on my background. Okay, to start off with, we will take a look at a simple structure I'm working on and decide how we will present these structural members to the fabricator. Okay, to get started, let's turn a few layers off, just so we can get down to the steel members only. Okay, now we're going to talk about the different components of the structure. First, we have the columns. And there's different types of columns mainly because they have different shear tabs going in different directions. We have different wall thicknesses in some of the columns. Okay, let's isolate these columns. So I've selected all my columns, and I want to grab a couple additional items. Select similar. We'll see if that gives us what we want. Okay, that'll give you a better look at the columns. So this is the first thing that would go in the project and be installed on site. So we have the anchor bolt templates, the anchor bolts, base plates, the column that's constructed of an HSS, and as I was talking, each column has a little bit different configuration of shear tabs. And this is a HSS 6x6 by 3/16, and then the exterior in the middle are 6x6 by quarter. So that's a good look at like the first components, and that'd be the columns, the start of the building. Okay, let's turn everything back on. Now I want to take a look at the second component of the building. Something else to think about is I like to break up my project into many layers. That way I can turn things on and off at my whim rather than have everything on the default beam layer. So now I'm going to select similar. That's going to pretty much select my frames. I'm going to add the shear tab, select similar, and if I shift and rotate, I can see that I have everything I want. So again, I'm going to isolate just to give you a better idea that all these frames are the same. The only difference from one side to the other is they're flipped around 180 degrees. But trying to make this project as simple and as repeatable and as profitable as possible. So the sway frames are the second component of the project. Okay, again we'll turn everything back on. And we'll look at the third and last component of the steel, that is. So again, because we have everything on layers, I should be able to select similar. Looks like that grabbed all of my truss. I'm going to also grab the shear tab. I'm going to isolate. And there we have it. There's the trusses. Again, these are all the same. So that's the major components of this simple structure. So then we'll talk about starting to detail our pages so that we can communicate what we want built to the fabricator. Okay, I've already set up all my documents, created all my pages. So now we're going to talk about the document manager. We'll browse the document manager and talk a little bit about what's in it. So the first thing in this document manager is the assembly drawings. The assemblies are things that have been welded or bolted together. So these drawings are typically for my fabricator. So the fabricator knows how to assemble the parts into the different components needed to build the overall steel structure. So an example is this is the sway frame. This is the truss. And then there's various columns. And we'll talk more about these assembly drawings later. Next is the GA drawings, or the general arrangements. The first thing I try to do is give the fabricator, and well, my entire shop really, the overall picture of what we're building. I've always been a lot better fabricating when I know what the whole picture is. To be spoon-fed makes it harder because sometimes I might make better decisions on how to put something together based on the overall project rather than just building that component. So that being said, after they see the overall project, and then in this particular project, I take away all of the lumber off the top so they can see the steel package exposed. Again, so they have a better idea what they're building. And then, since it's a real simple project, I'm moving right along into some really basic erection drawings. And this is phase one. After the concrete crew has set their concrete pier foundations and set their anchor bolts, templates, then we're ready to set columns on top of the foundations. So my guys in the field need to know what column goes where. That's why we have, these are all ID'd and shows what they are. Phase two, we're going to add the sway frames. Again, another simple step. Phase 3, we're going to add the truss.
I don't know what you mean by. Hey Siri, we're going to add the Travis. How about a web search for it?
That's hilarious. I'm going to leave that in. It's kind of fun. So again, we've set the truss. They know what the truss ID is, where they go. And then we're going to move on to phase 4, which is simply adding these wood nailers to the top of the truss. In phase 5, on and on and on. We're adding 2x8, a 2x8 roof system on top of it, which will later be covered by a steel roof. The owner just wants to be able to see these 2x8s from below, just looking for a certain look. Then I'll just add some pages in that I know my guys are going to need in the field. They need to know what side the shear tabs go, like when they're setting a panel or a truss. So this is just a real simple page with that information. And I'll add various pages with, just a little bit of information. Again, trying not to over detail. Some detailers like to just fill a page full of ink, thinking, oh, I've done good, I've got all this information. Sometimes it's a little more complicated, sorting through all of that, trying to figure out what's going on, when it might be easier just to have multiple pages with less information, where it's easier for them to break things apart. So again, we'll go over the GAs a little bit more in detail later. After that, this portion of the document manager is the parts, the single parts. And typically in my shop, this is, the first thing I do is take these drawings down to my Sawtech, my processors, and these simple drawings show them how to cut their parts, what length, and I like them to be just as clean as possible. There's no reason having any more information than I need. That being said, you'll see some redundancy. This is part BA36. Well, my assembly is part BA36 above. It's because the primary component of an assembly dictates the name of the assembly. So in this case, this tube becomes BA36 assembly. So I still like to give my Sawtech a clean single part so that he's not sifting through too much information, and he or she can just focus on task at hand, which is cutting parts to length. That being said, there's several different variations of single parts. Some are simpler than others, some are more complicated. We'll talk more about the single part drawings later. Okay, let's revisit the single part drawings. We're going to go to the first part in my single part drawings. So BA36. So what do I know about this part? I know that in my shop I'm going to put it in a shuttling saw. That saw needs decimal input. So this is 80.0365 inches with a 45 on each end. So in our saw, this is the Sawtech's going to put this tube in the saw. He's going to set his head to 45 degrees and he's going to make a trim cut on this end. After the trim cut, he's going to roll this tube 2 times. So that's going to oppose the miter from the saw blade direction. And at that point, he's going to make sure the tube is up against the backstop of the saw, and he's going to push the part to where this tip just fairly engages the blade of the saw. And he's going to shut his vices. He's going to type in the shuttling dimension, and he's going to let the saw start, shuttle, and cut again, and then that's going to create this part. Now if you were running a manual saw, you would set up your head to 45 degrees, make your primary cut. Your saw tech would probably pull a tape from, at this point, from this tip down 80.0365 inches, make a mark, use a speed square or a slide square or whatever tool he has available, and maybe possibly a silver pencil, and scribe the line across here at 45 degrees. Then he's going to line that line up with his saw blade and make his second cut, and then the part's done. So that's really the only information the saw tech needs to create this part. Okay, let's move on to the next part. See, BA37, same exact rules apply. Saw tech needs to know the miters and the decimal length in inches. And to show you a little tip since we're here. These oddball looking lines right here are called helper lines. They're used to help your fabricator or saw tech lay out. If you don't like them, you can double click on your part, go to the axis, uncheck the helper line, and it goes away. That is BA37. Okay, moving on, we'll take a look at a couple more single parts, and maybe throw a tip or two in there. Parts like this, I don't think I need to explain. I mean, it's at a 90-degree cut on each end. It'll either be shuttled or cut in a manual saw. Pretty easy part. Same with CA39, CA41. These are all the HSS, hollow structural shape 6/6 quarter. They're columns, so pretty simple. The more complicated parts are in the sway frames and the truss. So just meandering down through these, looking for something that gets our attention. Take a look at this drawing. Now again, some of these drawings, I don't have any more information on it than I need because my saw techs, they know how to handle this part. They've cut this part multiple times. I think we lost a couple of our dimensions, so we're going to reset them. This shows the 28.571 degree miter on each end. So in our shop, we're going to shuttle this through the saw from this point to this point. And we call that long to short dimension. And that would be long to short side of the part. So again, my guys know how to handle this part, running it through the shuttling saw. I may need to give more information on it if, let's say I had somebody manually cutting this. To me, this is pretty obvious. This is a 90-degree corner, but I still might add that information there. Do it on both ends. And then I'll try to clean up the dimension a little better. And just get it in a area where it can be read. Sometimes that's a biggest part of the struggle, is getting everything to fit, not be overlapping and too busy and easy to read. Just changing my dimension styles to match what I have on the page. But anyways, you get the general idea. I think that's pretty much all the information Saw Tech would need on this part. Okay, let's move on to a single part that has a little bit more trickery. So you, the detailer, you're basically providing information to the shop so they can do their job. So scrolling through some of these parts, I'll give you an example of let's look at BA19. So BA19 was just put this together. It's somewhat of a sample to show you that in some instances I may want to give the Saw Tech additional information, or maybe I have a new Saw Tech, so I need to explain to them how they're going to process this part successfully. So it's always nice to be able to add additional information, as long as you can keep the page clean and have clear instructions. Show you another trick. This right here is called the system line. It's also something that you can show as visible or not. So same thing, go to the axis, hit your helper line, and then your system line. So I just cleaned that up if that's something you choose to do, but that's how you turn that stuff on and off. Most custom fabricators' go-to measuring device is a tape measure. We need to understand where they're going to hook their tape or index their tape and where they're going to read their tape in order to create good dimensions. Okay, let's talk about something a little more exciting. We're going to move along to the assembly drawings, and I'm going to do my best to explain why I dimension the drawing the way I do. And that's basically based on the way I'm going to lay out my assembly, how I'm going to clamp it, how I'm going to tack it, and how I'm going to create that assembly in the shop, in the fab station. So that being said, let's isolate one of these sway frames. And talk about it a little bit. Okay, now that I have my sway frame isolated, we can take a better look at it. All my tubes are centered. They're all the same width. My shear tabs, one side of them is set to the center of the tube. So now I have to decide how I'm going to lay this out in the shop, which is going to determine how I detail my assembly drawing. So the way I would handle this in a custom fabrication setting is I'd establish what my primaries are, and that would be these two parts right here. So now I'm going to isolate those parts so we can talk about them. Okay, as a fabricator, I'm going to lay these out on my table or horses or whatever. Some shops love fab tables. We do a lot of laser leveled precision fabrication horses that are very adjustable, that we can set to any width, any length. So in our situation, I'd pick out my two primaries. I would clamp my first primary to my horses. We're talking about running horse under a third and a third of my parts, and I'd overhang each direction. Once this is clamped down, I'm going to measure with my tape measure from this tip to this tip, hanging my tape measure from here, reading to this tip. And I want to get my width set per my assembly drawing. I'm going to do that on both ends, back and forth until they're both exactly the same. Next, I'm going to cross measure, so I'm going to run diagonal tape measure from this point to this point. Then I'm going to measure from this point to this point. I'm going to do that multiple times until my measurements are the same, indicating that I'm square, as long as I still have the same width on both ends. Once I have the same width on both ends, my diagonals are the same, then I'm 100% clamped out. This thing can't move. Then it's time to add my next parts. Alright, let's review the corresponding assembly drawing and go over a couple dimensions based on what we just talked about. So we decided we were going to set our primaries, which is this part and this part, and we were going to set them to a width, which is this dimension, 24 inches. And then we needed to set our diagonal dimension, and cross diagonal dimensions would be the same. Therefore, I only need to put the diagonal dimension on my drawing one time. Putting another diagonal dimension on the other side is redundant, and it clutters the paper more, and we want to keep it as clean as possible, especially since we all know that the dimension is going to be the same, 83.642. That being said, we'll go back to the model and talk about the next phase of laying out the assembly in the shop. So in the shop, the fabricator or myself would have these two pieces set. The next step would be adding what I want to call the secondaries. Setting the secondary, my fabricator or myself, they're going to pull their tape from the end of this tube, the end of this tube, to the end of this tube, and that's going to set the length of this steel frame. So these four pieces would be my next step in laying out in the shop. Then I would add my, what I'll call an intermediate, and then last I will add my diagonals. So again, just my terminology. Primaries, secondaries, intermediate, diagonals, and these would be our accessory pieces, which are our shear tabs. So fabricating phase 1, phase 2, phase 3, phase 4, I'm going to drop my diagonals in, and then I have a tube steel frame all tacked up, and then I'm going to use flat bar and clamps to create a jig, and I'm going to build my remaining 7 sway frames on top of this assembly, because I have just created a fixture for the rest of them. The last thing I'm going to do is go back and add my accessory shear tabs to the end of my frame. In our shop we have special spacers with flat bars we would clamp on our tube steel frame that would set the elevation correctly for the shear tab. We'd tack it, then we would weld out the assembly, clean them up, get them ready for paint. So let's go back to our assembly drawing. So once we set our secondaries in our drawing, we need to know what that overall length is, which would be this 80.125, 80 and an eighth. Then my next phase would be to set my intermediate, so I need this dimension, 38.5625. And then I'm going to drop my diagonals in, and they're pretty much going to, you split your gaps, split the difference, make sure everything's the same, and they're going to pretty much fall into place. That being said, I'd still probably have a reference line on the inside of my part, and it'd be this 7.5 and this 72.6, and also these two 34.05 dimensions on the other side. So the way that a custom fabricator would probably do this is he would pull a tape from his outer edge of this part and read to this outer edge and make sure that he is at 80.125. Then he has his primaries and secondaries set, and more than likely at this point he would tack those into place, and then he would set his intermediate. Again, they're gonna index or pull their tape off the tip of this. I would use a silver pencil and I would make marks progressively down my tube, and then I would transfer my lines over to the interior side on both tubes, because I need to know where this intermediate is going to land on both sides, on both tubes. But I only need this dimension on this one side. So on the second side, though, I'll add these lines on the interior side of my tube, so I know roughly where those diagonals are supposed to hit. So that's about the cleanest way I could come up with dimensioning this to where I wasn't too cluttered, too much going on, and the right information. Next, we'll look at our other bottom viewed below, and it also references the overall length of the tube steel frame, and then it has the overall length of the entire assembly with the accessory shear tabs installed. And then another important dimension would be, as I referenced earlier, the shear tab is, one side of it is set from center of tube, which is 1.5 inches, and I also have included that dimension. So this should be enough for a good fabricator with good shop experience that's familiar with reading shop drawings. You should have enough information on this page to correctly lay out his assembly. Alright, next let's isolate our truss. The truss is a much more complicated piece. Alright, so I'm going to select components I know that are on the same layer. Select similar. Isolate object. And to make it even simpler, we're going to just isolate one of the trusses. There, now we can just focus on one thing at a time. Okay, as a detailer, I got to put myself back in the fabricator's shoes and say, how would I lay this out? In my case, in our shop, based on our tooling, I'd probably have this truss set under 4 trusses, or I'm sorry, 4 horses. So I'd probably have a horse in this location, this location, this location, and this location. That being said, I have to figure out on this odd shape what my primaries are going to be. And I think for me, I'd probably set the 2 top parts of the rafter or truss, and that would be my 2 primaries. I would set this with a digital protractor, and once I got that right, and I would just have it clamped together with flat bars, no tacks involved. Then I would add the lower portion of the truss. This would be, I think, the 3 components that I could successfully start my shape with. Alright, based on what I just said, let's review the assembly drawing for the truss again. Okay, based on this part and this part being our first two components, and talking about our digital protractor, this is the degree that these two components would need to be from each other. And then we would add this third part in. So this would be our dimension that we would transcribe across to this side of the tube, the 9.8640, and back over here, 9.8640. So the first thing you would do is you would lay out your marks on the inside of your tube on both this part and this part. So after they're up on your horse and their horses and they're clamped down, then you have reference lines to pull your parts to. That being said, I would back up a little bit. This is an end cap that encloses the end of this tube. End caps are the very first thing that we put on our single parts in the shop. So you have a bunch of components, you put all your end caps on because it's the easiest time to do it, because they're easy to flip, rotate, and grind, so forth. You don't want to be grinding the ends of this tube when you have a great big truss that is hard to flip over and get to different portions. We can weld in the flat position, roll your tube, weld again, roll your tube, weld again, roll your tube. It's very simple when it's just on a single tube rather than trying to do it later. So end caps are always first. Therefore, my dimensions always come off the end of the end cap and not the end of the tube, because I won't be able to measure that anymore, or it will be very difficult. So again, we would make sure that we had our silver pencil marks, or whatever marking device you use in your shop, would have all our reference lines on both of these top tubes, and then we would have our reference lines on our bottom tube, so that we can set this tube the correct distance off the end of our top piece on both ends. Okay, back to the model. So again, we're going to use these three tubes to create our primary shape, and then we can drop our diagonals in, and then my next choice would be to drop these two pieces in, and then the other side. And then last, I would add my accessory piece, which is the shear tab. Now I take that back. Yeah, see, sometimes you got to back up a little bit. I would not put on my shear tabs at this point. I would be at this point. Because this is all tube still. They're all the same flatness. They're all centered on each other. Therefore, again, I can create my fixture for the rest of my trusses once I'm at this part of the assembly. So again, I would This becomes my fixture or my jig, and I lay my other parts on top using flat bar and clamps, and I build my other 4 trusses, and then I add my accessory piece, which is my shear tab on each side, tack that, and lastly I add these 2 angles which on each side. And what these are for, this is what we attach the 2x8 nailers with screws from underneath. So that would probably make the most sense in how to assemble this in the shop, which I need to make sure that I have all the correct dimensions for the fabricator in whichever direction he decides to put this together. Okay, last look at our assembly drawing for the truss. Like I said again, I think I have all the dimensions on the truss to lay out all the single parts. We also have an additional view at the lower corner of the truss, so we know again that we have to put this shear tab on one side, center our tube 1.5 inches in, so that it will fit correctly in the field. We also have our compass showing which way they are going to be installed in the field based on this tab location. We also have all of our part IDs or labels. Again, I think we're at a point where a skilled fabricator with experience would be able to lay this out. Before leaving this page, let's clean up a few of my labels. They're not even with each other from left to right. So I'm going to select the label, right click, arrange label, select the other opposing label, and that'll even them out. So same thing, I'm going to select a label, right click, arrange label, select the opposing label, and they're evened out. So that looks a lot better. Okay, we're getting pretty close to the finish line. One of the last things I want to go over is columns. So again, I'm going to select the different components that are on different layers that I want to see. Then I'm going to right click and then select similar. And I'm going to isolate objects. So we can talk about any of these. So we'll just pick one. Okay, so now we have a column. Oh, an important note too. Your columns need to be in the column layer. Here. Reason is if they're not in the column layer, and when you're creating drawings and you add the compass to it for their orientation, if it's in the default beam layer, your compass will be pointing the wrong direction because it doesn't understand that it's vertical. So that being said, again, I'm going to look at this column and decide how, as a fabricator, or put myself in the place of a fabricator, say how would they put this together. In our shop, again, first thing we always do, weld on end caps. Again, so we can easily rotate the tube, get to all the positions of welding easily, grind and finish the top cap easily because we can rotate it. After that, I'm probably going to hook my tape on the end of the tube and lay out each side lay out my marks for my shear tabs, I'm going to lay out the edge of it and the side of it on my tube, so then I know where to place it. And then lastly, after my shear tabs are on, I'll probably install my base plate. Then I'll weld the entire column assembly out, and again, clean it up, ship it to paint. Okay, let's take a look at a column drawing. I have a few non-traditional bits on this page, but I need to make sure that my fabricator clearly understands how to assemble this column. So that being said, I have some additional notes at the bottom of the page. Let's take a look at that. SB equals sway brace connection. So BA56 is 91 3/4 of an inch from top of base plate. So basically what I'm telling them is this BA56 shear tab is 91 3/4 of an inch from top of base plate. So again, the fabricator is going to more than likely lay out this shear tab before the base plate's put on. So he will still end up with the same dimension, hooking his tape over the end of this tube, reading his tape at 91 3/4, making his mark. And for that shear tab, he also needs to know where it's located from the side of the tube in. And in this instance, it's same thing. Trying to put all my shear tabs, one side of them centered on the tube, so it's 3 inches on a 6-inch tube. Okay, so going backwards a little bit, every fabricator, when he gets a drawing of an assembly, the first thing they should do is inventory all their parts. Make sure they have the right quantity of parts. Make sure that all the parts are cut to the right length, holes are in the right location, etc. And doing that, let's say they were going to look at this base plate. They don't need the dimensions for the holes on this page, because this is an assembly drawing. They need to check their hole layout and so forth on the single part drawing. The reason I do that is I don't need that additional clutter. If we put all the dimensions of the base plate and the holes and the shear tabs, there's going to be a lot more dimensions on this page, and it's going to start getting cluttered, and that's when it starts getting a little confusing, and you're tracing and tracking down dimensions. So I just do that in a way to keep my pages cleaner, because as we all know, you could have multiple shear tabs on a very long column, multiple connections. It gets really busy really fast. That's one of the reasons I have, like, on this view over here, the top view, I show the 2 3-inch dimensions because I can fit them in well. But with my labels, it's hard for me to put this additional dimension here without being too cluttered, so I just put it straight across from it. It's pretty easy for the fabricator to find that dimension. And another thing I'll do is I'll try to do that every time that I can. If I have this top plate on this column, I'm probably going to put it over here, and that way that fabricator will get in a habit of looking for it in the same place as he goes through this project. Okay, and another thing is my Sawtech will get a single part drawing for this tube, and that's all it'll show. But I also have the cut length shown here for the fabricator, just to double check if he doesn't necessarily run back to the single part drawing. That being said, you can see the dimension goes from top of base plate, which is end of tube, to the end of the tube on the other end. So that's my cut length. I also have an overall length above, and then I have my 2 shear tab dimensions from top of base plate. Okay, taking one last look at our column, I think I'm going to add another dimension to this. My guys would know these holes would be 1.5 inches in off the edge of plate, but let's just say, let's add it so that we can be crystal clear. Now I have a little bit of problem with cleaning this up, so I'm probably going to move my label over, move it out of the way a little bit. And this 1.5 inches off the edge of plate happens on every shear tab, so I could add a little note. And we'll pull it out to where we can see it a little better. And I think that clears that up quite a bit. And the last thing we'll do is just look back at, like I said, I don't want any extra dimensions on this page that I don't have to have, so we'll look at this BPA 33. This is a single part drawing. I have this laid out two different ways. One way is pretty much off center, which is, you know, the AISC way. The thought process there is if for some reason you cut a plate, you know, maybe a little bit short or it's a little bit long, you can work from center out and your whole layout will be correct. Anymore with like our shop, we just pretty much cut our plates the right length. We have a shuttling saw that it's almost perfect every time. So we have it laid out the AISC way, and then we also have running dimensions on it. You know, my guys will grab this plate. If it's cut perfect, they'll just lay it out with running dimensions. So in this case, I just did it both ways. And then on the shear tab, they're very simple. I'll put running dimensions on that as well. You know, and with advanced steel, you can quickly change that. And then I have multiple styles of drawing or dimensions, but you can change it back to the you know, whatever your preferences are at the shop, whatever you think looks good. So that's the shear tab that's on this column. This is the base plate that's on that column, and then this is the assembly drawing. And again, that's just my way of keeping it as clean as possible, is only putting the dimensions I need to assemble this. All right, let's take a quick look at some of the GA drawings. Most of the GA drawings are pretty self-explanatory. We went over a little bit of this earlier, but maybe we'll take a look at a couple of the additional pages I put in here for additional information. GA Sheet 8 is a good example. This is an additional page I put in here for my guys in the field so they would understand what side of the shear tab on the column their sway brace panels and their trusses would go. So a good example is, we'll look at detail A here. Of course, when they're in the field, they can't zoom in on paper, so they can do a lot of squinting, but that won't solve the problem. So what I did is just give them a little blow up of that section there, so that they could see the column shear tabs all the way around, and then the related shear tabs for the truss and the sway brace frames. So I did that in both detail A and detail B. And then at our shop, we we don't just give them a handful of paper and send them to the field. I'll actually sit down with my field foreman and go over these pages and make sure he understands before he goes out there, and then there won't be any issues. All right, another additional page. GA sheet 11. Again, not a lot going on. It's not overpopulated. Pretty clean page. But necessary page for the people installing lumber. There's 132 pieces of PA-47, 2x8 planks that cover the roof. There's a PA-48. It's pretty critical to know that person installing the PA-48s, which are the nailers that go on top of the truss, they have an 1.5-inch overhang at the bottom. So this page was added so that it was clearly understood, and again, so that the project would be successful. One of the last pages, but probably the most important, is the anchor bolt settings. The concrete crew is going to set the foundation. The foundation is, if you don't have a good foundation, you don't have a successful project. You have to have a good foundation for everything to start off right and to finish right. So this is a very simple structure with a very simple foundation. Therefore, there's not a lot of detail. I mean, we have the same anchor bolt template throughout all 10 locations. So the most important thing is that all the information is there. Again, running dimensions, so the concrete crew can properly lay out the length of the project and the width of the project. We also show what column goes at each location on this drawing, and we show the diagonal. Again, we only need one diagonal because both diagonals should be the same in order to be square. Again, very simple but very critical drawing. Alright, last thing that we're going to do at our shop is I'll sit down the shop foreman, kind of review the 3D model in advance still, so he has a much better idea of how this thing is going to be put together, what he's building. And that's also gives them an opportunity at that point to ask for additional dimensions or ask for an additional page in the drawings. Something that I would oversee, which is very easy to do. I mean, as a detailer, we get submersed in the drawings, so at some point we understand the project better than anybody, but you always need a fresh set of eyes to take a look at it. And the last thing I'll do is I'll print out a packet and let them sit down for 20-30 minutes and review the drawings in detail, and just again make sure there's nothing else that he sees that we need additional information. So that being said, we're also gonna start putting pictures of this on LinkedIn, because we're gonna build this in a very near future, and it'd be kind of interesting to see the progression of it go. And since you've seen the class, you'll be able to relate to it a little bit. So that's pretty much going to wrap up this class, and detailing it and communicating with the fabricator. hope to see you on a future project. And thanks for being patient with me. And we'll talk soon.